to Science Sunday. Here we are, 5 days before Christmas, December 20th, and the weekend in which we are enjoying our winter solstice. Happy solstice to all, and to all a good night. Tomorrow marks the shortest hours of daylight in our northern hemisphere, and also, paradoxically, we are at almost our closest distance to the sun. We'll be closest actually on January 2nd at 7:51 a.m., so set your clocks. We'll be a mere 91,399,453 miles away from it at that point, so put on your sunblock. Relatively speaking, the farthest away we'll be is in July 5th, when we'll be 94,510,000 miles away from the sun. So obviously relative distance has nothing to do with the length of days or of our current temperature. At the moment, however, because we are closer to the sun, the Earth is moving the fastest it ever does, more than a half a mile per second faster than the Earth does in midsummer. That may be why you are a little bit behind in your holiday shopping and why we're starting a little bit later than you'd expect today as well, too. Truthfully, in the northern hemisphere, our summer season lasts nearly 5 days longer than our winter season because the Earth is moving much slower when it's out at its farthest distance from the sun. So that's something we have over Australia and New Zealand. We get a longer summer than they do. Little fun facts about the solstice and things to start your day off. Today, Scott's going to take us on a cosmic journey. Before he starts, I'd also like to introduce you to Dr. Steve Natz, a friend and participant in Science Sunday. Come on up a second, Steve. He's here to...
Thank you, Mike.
Okay. He's been involved with Science Sunday with me a bit. His background is in rehabilitative medicine, but he's a fellow biker, a historian, and science lover. He's written a novel that I just finished reading about Franklin. So Steve will lead a Science Sunday in February, and he'll dispense his knowledge and interest to the group of science lovers as well. So I'm excited. I'm looking forward to hearing Steve's insights in the meetings we will have in the future, and I think it'll be an interesting time to bring in other ideas. So welcome.
Thank you.
All
nice
right.
to be here.
We thank the UU Church for its support, and each of you for your participation and friendship as well. Next month, I'm going to discuss vaccines, which I think is kind of a timely subject. And so that'll be January 2nd, I believe, is the first Sunday in January coming up. So here we are at the end of 2020. I hope that you're getting through it with forbearance and strength. And we're here to help you think of science things on the way, too. So without any further ado, Scott, to talk about Christmas, cosmic Christmas. You may want to mention about the live stream and so on.
Yeah, the live stream, right. Can you still hear me if I'm over here? I want to make sure everybody can get a gander at my sweater here. So I have a couple of ugly Christmas sweaters, and, you know, I try to be thematic with them. This one, the theme is sort of aliens and outer space. So in line with my sweater, I want to talk about the wider cosmos. And specifically, I want to talk about some of the most beautiful things we know about in the sky. But I want to thank all of you who've tuned in here to the live stream. If you would like to ask a question or send in a comment, Mike today is monitoring the YouTube live feed here with this laptop, and so he'll be able to see your questions, comments, cheers and jeers, etc., should you wish to type them in on the YouTube stream. I think that's it for housekeeping. Let's go ahead and dive into cosmic ornaments. So let's make sure that this clicker is working here. Well, so far, let's see, it says...
You have to push it to the...
It's got the...
green shows.
Yeah, green does show. It's on. Let's see here. Might be having a little bit of a technical difficulty.
Justin, you have any ideas about...
Yeah, hang on, guys. It's changing.
Oh, okay. You want to restart it, or? That's strange.
I think it has to do with the speed of the Earth. We're moving a little too fast to keep up with the...
Right. That's one of the great cosmic puzzles, how to get PowerPoint to work consistently. And it's unsolved mysteries of science, of which there are many. We have Steve in the rafters helping us today, up in the skybox, right? Mm-hmm. So I hope you all don't mind. We'll probably run a little over our allocated time here today because of some of the technical issues, and I have a lot of beautiful, literally beautiful things to get through, talk about today. I hope that as I'm talking about these, I also convey to you some of the science surrounding the different sorts of objects that we're going to look at. We're going to look at things like exploding stars. We're going to look at giant clouds of gas and dust that speckle the cosmos and our galaxy and others. We're going to look at galaxies. And some of these things are just spectacularly beautiful. You know, it was only about 100 years ago that scientists figured out that galaxies were independent island universes, that's what they're originally deemed, that are outside of our own universe. Or, I'm sorry, outside of our own galaxy. The Milky Way galaxy, you're all familiar with that. The Milky Way is one of billions, perhaps trillions of galaxies that were generated during the Big Bang, or subsequent to the Big Bang. And discovering that galaxies existed outside of the Milky Way was an epochal discovery of astronomy.
I'm always amazed when you hear they talk about how there are so many billions of stars and galaxies and so on there, and they're more than there are grains of sand on all the beaches on Earth.
Yeah.
And that's amazing. And then I've been reading some stuff more about the bacteria and the things that are inside our body, and each of our bodies has more bacteria than there are stars in a galaxy. And this
My goodness.
Just phenomenal.
Yeah, the numbers just overwhelm.
The numbers game is just incredible.
Yeah. Yeah, it takes a lot of stars to make a galaxy. I think, isn't it true that there are about as many neurons in your brain as there are stars in the galaxy?
Yeah.
So
Yeah.
you've got a...
In one person's brain, yeah.
Yeah. Not to mention the fact that there are about 7 billion of us. So, all right. All right, I'm going to try this slide clicker again, see if this works. There we go.
Yay.
All right, thank you, Steve.
That's not Steve.
Oh, I'm sorry, who is this? Todd. Thank you, Todd. All right, so before I get into some of the more beautiful cosmic ornaments, I would be remiss if I didn't mention something happening today and tomorrow, and that is the great alignment of Saturn and Jupiter. I recommend that if you have a pair of binoculars or a good telephoto lens, 200 millimeter, 300 millimeter zoom lens you can also use, you can zoom in on the bright spot. So this is a simulated image from a program I have. This simulated image depicts the night sky, the evening sky tonight, about 5 p.m. And you see the glow of the setting sun in the southwest. This is looking almost exactly southwest in terms of compass directions. And you'll see a bright spot just above the horizon tonight about 5 p.m. and it'll set about 6 p.m. So you don't have much time. It's also supposed to be partly cloudy tonight, so good luck spotting it among the clouds. Astronomers, both professional and amateur, call partly cloudy skies, they say that it's festooned with sucker holes. You sucker, you thought you could see something tonight, but no, we're putting a cloud there instead. So I hope that I and you can see it. I'll be out there looking for it tonight. And it'll look like a single bright dot, but Jupiter and Saturn are not colliding. They're still going to be millions of miles away from each other. They're just going to be aligned with our line of sight. And they're even not going to be the images that we see of their light is not going to overlap. There's still going to be considerable distance between them. So this is a simulated view of what it might look like through some high-powered binoculars or a modest telescope. So,
Todd, are you able to zoom in on just the picture there?
yeah,
Scott's picture?
just make that the primary thing that people are seeing online, if you can. But if you've got a moderately high-powered telescope or a good pair of binoculars, you'll be able to spot that as you'll be able to spot the moons of Jupiter as well. And then, Todd, also some of these images I'm going to display, it would be better if the slide portion of the video feed can take up more room. Maybe if you can expand that to just over Mike's head or something like that.
He's working furiously.
Yeah, he's working there. We can give him time. I don't have anything else to do this afternoon, so.
I've got a few things planned.
Do you really? Well, you can leave.
Okay.
Yeah, Steve and I will stay here. We'll get it done.
But they were with you guys.
Oh, that's true, yeah. As long as Todd's willing to bear with us, I appreciate your help. This so-called conjunction of Jupiter and Saturn hasn't happened for about 800 plus or minus years. I don't remember the exact number, 880, something like that. But last happened about the time of Galileo, one of the first people to look at the night sky with a telescope. And Galileo and his telescope would not have been sufficient to get a crisp view of those planets, but he could see at least the moons of Jupiter. And so those are called Galilean satellites in his honor. And I believe he wanted to name those satellites after some of the popes, if I remember correctly. And eventually they got given mythological names consistent with the names we've given to a lot of other celestial objects. So the Galileo, even through his modest telescope, one of the first ones to look at the sky, he would have seen this same kind of thing, Jupiter and Saturn. So
Now, people can probably see there's a lineup of all these. Can you identify what planets you're seeing or what all those things are? Is that?
yeah, so the bright spot up in the towards the center of the top part of the image, that would be Saturn and its rings. And then the line of things down towards the center of that picture, the sort of dim, large spot is Jupiter, and then the brighter dots aligned with Jupiter are Jupiter's moons.
Wow. So that the kind of darker gray one is like third up from the bottom right is Jupiter.
Right.
And then there's 1, 2, 3, 4, 5 or so stars, 5 planets, or 5 moons really aligned with Jupiter there.
Right.
And the other one high and top is Saturn.
Right.
Okay. Okay.
Todd, is this something you're able to help us with, or? Okay. Well, let me just go ahead and move on. All right. So this is a image. I've used this spaceship before. This is my homage to Carl Sagan. Carl Sagan had the spaceship of the imagination, and I think Neil deGrasse Tyson took over as its captain during his couple of seasons of Cosmos. This is my imaginary spaceship, Daydream, and it's a mock-up of a NASA scientist created this fantasy of something potentially what a spaceship that could take us to the stars might look like if we were able to find something in the universe called negative energy. And unfortunately, nobody has any idea what that would be or how how to possibly make it.
I'm researching a lot about negative energy on the weekends.
Really?
myself, Yeah.
Yeah, that's good. Well, maybe you could power us to the stars then.
Yeah. They'd have a lot of couches in there in my case.
Yeah, so this would be something powered by an Alcubierre drive. It's a scientific idea for a warp drive that requires this exotic energy that nobody knows how to create or find. But in any case, you know, in the past we've used this Daydream imaginary ship to go back in time. We've used it to travel the cosmos. Fortunately, today we only have to take it up into near-Earth orbit, because it's going to be parked about the same place as the Hubble. Most of the images I'm going to show today come from the Hubble telescope and a couple of other orbiting observatories we have. And because of that, they're all courtesy of NASA and the European Space Agency, who manage those telescopes. So I want to give a shout out to the legions of scientists, technicians, engineers, artists, et cetera, who have helped acquire and process some of these images. So next up, we have, whoops, there it goes. It's not clicking again. I don't know, oh, there's something happening. I wonder if it's related to the relative power of the computers here versus the one I have at home. I've got some embedded motion graphics and whatnot on this. Might also be the version of PowerPoint, I'm not sure. So let's see if I can scroll forward. Well. Okay. Okay.
Todd says it's moving up on his master computer up there, but it's not changing it on the printer, so he's going to shut down and restart up.
And don't worry about recording the timings. I can deal with all that later. Apologies for the technical difficulties. My slides are overwhelming the poor projector, apparently. They're just too beautiful for words or projectors.
So do you go on a certain website to get these pictures, or how are you acquiring these pictures?
So
Where can people see them?
That's a good, great question, Mike. Thank you. A lot of these are available directly from the NASA and European Space Agency websites. They publish Hubble pictures and whatnot. But most of these I've taken from Wikipedia. So a lot of those pictures from NASA and the other international space agencies make their way eventually to Wikipedia articles about some of these objects, because they are the best pictures humanity has available for some of these objects. So one of the tricks, however, is knowing what to look for, like any encyclopedia, right? You have to know, you can't just say, well, I guess you could just say galaxy, and Wikipedia would show you some information about galaxy. But to find particular photographs of particular galaxies and particular exploding stars and whatnot, you kind of have to know what to look for. And a good way to browse through them is just to go directly to the NASA websites, and there's galleries of pictures that you can see there.
And they're all named in some way,
Right.
The horns of Zeus or whatever.
Yeah, could be. Didn't know Zeus had a pointing, but maybe it could have. All right, so you know, I've decked out my Daydream imaginary spaceship appropriate for the holidays. So we've got some punch there and eggnog and whatnot. So here we go. Let's embark upon our cosmic journey. And that seems to be working great right now. Thank you so much, Todd.
Is it still possible, Todd, to get basically what's on your computer onto the screen? Cut out Scott and I more than?
Yeah, make us smaller and the image bigger. Right now the image is really tiny.
We're working him up there.
Yeah. Thank you so much, Todd. We really do appreciate your help. I'm not trying to be a pain.
I think the
Well,
Why don't you stay with the image?
Yeah. People have seen us for 8 years, and I know that my sweater is quite spectacular, but I think these images will be even better. So unless there's any specific complaints from our viewers online who can type them into us, let's just toggle to the slides.
There we are.
Excellent. Thank you so much.
Yeah, we're on our way now.
Now I
The
can,
journey has started.
yeah, here we go.
Got our warp drive up and going, and
All right. Here we go, launching ourselves into near-Earth orbit among the stars, which are, you know, the closest ones. What'd you say it was? About
91 million miles away about now.
91 million miles away. The rest of them are, oh, I don't know, 20 trillion or so. That's the closest ones. So here we go. Cosmic ornaments. So the first thing I want to pull up on our view portal is this cluster called the Wild Duck Cluster. This is one of the densest clusters of stars in our Milky Way visible to us from our location here around our sun. And one of the interesting things about the stars in this cluster is that they all are fairly metal-rich. Now, in the parlance of astronomers, a metal is anything besides hydrogen and helium. So carbon is a metal, oxygen is a metal, silicon is a metal, whatnot. It's a little different than material scientists and their vocabulary. So when astronomers say that these stars are metal-rich, one of the implications of that is quite scientifically profound. It means that a lot of these stars have incorporated material that has been synthesized into heavier elements by prior generations of stars. So you see all kinds of colors, you know, talk about gorgeous colors of stars. We see yellow, we see red and blue and white stars, and you almost never see a green star. In fact, I don't know of any green stars, but our sun actually puts out a huge amount of its light in the green wavelength of the visible light spectrum, as do many other similar stars. But we don't see our sun as green because it also puts out red and yellow, and green, red, and yellow combined make white. So our star we perceive as white. You know, we've evolved to have eyes that are sensitive to the wavelengths emitted by the greatest producer of light in our environment, which is the sun. And so the light of our sun is neutral or white. Now you see the sun sometimes as yellow or red because that white light gets filtered through our atmosphere, and that's why our sun may look, for example, red during sunrises and sunsets. The sun itself isn't changing color, it's just the changes in the light as it is scattered by our atmosphere. A lot of the blue light gets scattered, which is why our sky looks blue. But this is a picture from, probably from a telescope here on Earth, but the light of these distant small stars is not particularly significantly scattered by Earth's atmosphere, and these are pretty much the true colors of these stars. They're metal-rich. This cluster is about 300 million years old, and it has about 11,000 times the mass, total mass, of our single star, and it's about 6,000 light years away. The Wild Duck Cluster. I don't know, Mike, can you see a wild duck in this?
Just if it was hit by a shotgun. Oh, there it is. Okay.
Yeah, it's, you know, you kind of have to squint to see it, but yeah, it's clearly a wild duck there that's depicted in that.
And only 300 million years old. I mean, there were vertebrates on the Earth before these stars came to be.
That's right, yeah. You know, the big Cambrian explosion about 500 million years ago, and you know, 100 million years or so after that, you got animals crawling on land. So about the time animals with backbones and spinal cords arose, these stars were just being created in a nebula. And the metal richness of them likely came from prior generations of stars that were short-lived, that exploded and sort of peppered these with richer metal elements. All right, well, let's move on. Speaking of clouds of stars, so this is a photograph by an amateur astronomer, Ignacio Diaz Bobillo, and this is one of the most spectacular clouds of gas and dust visible from Earth. This is in the Large Magellanic Cloud. So the Large Magellanic Cloud is one of the nearest galaxies to us, maybe the nearest relatively large galaxy. There's also the Small Magellanic Cloud and some dwarf galaxies around. But the two big galaxies in our environment are the Milky Way and the Andromeda Galaxy, which I'll talk about more later. So this Tarantula Nebula is located in the Large Magellanic Cloud. And this is a region of glowing hydrogen, largely hydrogen, but it's also got some oxygen and carbon and some other elements in it. But the hydrogen is the most visible gas. And as we've talked about on other Science Sundays, hydrogen is the element that was synthesized in the early stages of the Big Bang. And then stars have formed from collapsed clouds or globules of hydrogen. And those collapsing globules, they build up the pressure and the temperature inside because of that collapse. And eventually it gets hot enough to ignite nuclear fusion. And it's that nuclear fusion reaction that literally lights up the stars. So in gas clouds like this, and by the way, this one is about 160,000 light years away, and it's about 1.8 thousand light years across, so 1,800 light years across, maybe 3,000 light years total, and pretty big for a cloud, much larger than a cumulonimbus or any kind of cloud around here, large enough to span many times the distance between us and the nearby stars. So it's a gigantic cloud of hydrogen. And within this cloud, there are new stars being born. Some of those stars are massive, hot stars. Those of you at home might be able to see the really bright bluish center of it, and then looking directly below that bright center, sort of to the southeast, you see a kind of a chasm where it's less glowing material. And if you look really closely, there's kind of a bright garnet-colored star right next to kind of a little hole, a dark hole. And I don't have a laser pointer that I can show it to you with, but that bright red star, one of the brightest red stars there towards the south, is near where that supernova happened in 1987. So the 1987A supernova was a supernova that occurred from one of the stars that was newly born, meaning 100 million years or so, from this Tarantula Nebula. Mike, can you see a tarantula in here? I don't know.
Yeah, in some ways, maybe a central body and
Yeah.
a bunch of limbs coming out.
Yeah, and make a beautiful ornament, I think, Christmas ornament. So, oh, hey, there's the tarantula. It was hiding all the time.
Now, the colors on here, the colors are a matter of the filters that are used that specifically, this isn't visual all, there's X-ray photography.
Yeah,
and
often. So this is just visible, though. So the guy who took this picture, Ignacio, he didn't have an X-ray telescope. He was just using a regular optical telescope. And you do put some filters so that you can highlight the light color that is specific to hydrogen. Every element has its own specific signature colors. And because the universe is festooned with hydrogen, much of the light that we see from clouds of gas in the universe is light from hydrogen. So you can put filters on your camera attached to your telescope so that you emphasize that hydrogen light. And it really is a red light. Oxygen tends to be a little blue, sulfur tends to be a little yellow. So quite literally, by looking at the optical colors of these lights, you can get a sense of the element composition of some of these clouds. And then, of course,
further they can do waveband.
Right, you can run it through a spectrograph and whatnot and really get the details about what are the materials. But this is largely just a gigantic collection of hydrogen gas.
Which allows them to say that such and such planet or such and such galaxy is very oxygen rich or carbon rich, and they can start looking for potential planets that might have life.
Right, exactly. So let's go back closer to Earth, moving through the interstellar medium, and we see a giant cloud of gas and dust in our own galaxy. This is called the Orion Molecular Cloud Complex. So this is a long exposure amateur photograph. So these sorts of photographs are so wide angle that, for example, the Hubble telescope and some of the bigger telescopes on Earth could not make these photographs. They have too narrow a field of view. So these kinds of photographs, like this one, is taken with something like a 200 millimeter camera lens from a very dark sky. And then you take a 10 or 20 minute exposure, maybe you take 5 or 10 of those, and then you combine them with some special processing software. So this is the kind of photograph that is particularly relevant to amateur astronomers. Not that professionals aren't interested as well, because this molecular cloud is of cosmological significance. So the three bright stars in the center of the image, that's the belt of Orion, and then hanging down there you see at least one kind of fuzzy star and another bright star, that's the sword of Orion. So largely this is the constellation of, the whole constellation of Orion is embedded in this Orion Molecular Cloud Complex. And the Tarantula Nebula that I just showed you is about 4.5 times bigger than this. So the Orion is big. It's the biggest one that we see, and it's relatively close to us in our own galaxy, but its total mass and size is dwarfed by the Tarantula Nebula. The central part of this, the central loop, you see the bright fringes around the belt and the sword of Orion, that kind of circular ring of glowing gas. It's thought that that's the remnants of a supernova that exploded about 2 million years ago. It's called Bernard's Loop, that sort of circular feature around those central stars that takes up much of the frame. Here's more of a schematic. Who's that? I don't know. Some visitor just.
I saw a red light flashing through there for a second.
Yeah, I don't know not sure what that was. Anyway, we've got, here's a depiction of the stars in the constellation Orion. So you can easily see the constellation Orion with your unaided eyes. And this just gives you a sense of how gigantic some of these molecular clouds are. But they're so faint, the number of photons they emit is so few, relatively speaking, that compared to the stars around them, that you can't really see it. You can't see this glowing gas. And also the red that is characteristic of hydrogen is just at the limit of human visual acuity. So it's really difficult to see without a camera.
Unless you say Beetlejuice 3 times?
I'm not going to do that. I don't want to jinx it. All right, so this thing embedded in the Orion Molecular Cloud is one of the most famous objects in the sky. It's a frequent target of amateur astronomers, and it is the Great Nebula in Orion, or the Orion Nebula, M42. So let's take a closer look at this creature. So here's the Orion Nebula, and this is a photograph similar to what I have taken in the past. Amateur astronomers can certainly take photographs like this with an investment of $3,000 to $6,000 in equipment. So it's not easy, particularly, but accessible if somebody wants to commit to this sort of hobby. And this is a magnified portion of the Orion Nebula. Now, using the Hubble Space Telescope and other scientific instruments, this place is a nursery. It's literally a stellar nursery. New stars are being created here all the time. And scientists are really interested in the processes of star birth and star creation. So, by the way, this is one of the first known photograph of the Orion Nebula. This is from an astronomer named Henry Draper from 1880. So this is a sort of a professional telescope from 1880 compared to what an amateur telescope can do, the image right behind it. So we've come a long way. So anyway, astronomers can zoom in on parts of the Orion Nebula as well as other places, but within the Orion Nebula they find these little globules. And these globules are new stars that are being born within this cloud. You can see the sheaths of gas and dust that are obscuring the brilliant pinpoint of light embedded in some of these zoomed-in little globules. These are pre-solar nebulas, protostellar nebulas, and literally see stars being born. Now, it takes, thousands of years for gas and dust to collapse sufficiently and ignite a star. So I don't know, I've never heard of a particular star at the moment of its nuclear ignition being captured on film, but these are certainly newly born stars. And then nearby, still within the Orion molecular cloud complex, a little bit distant though from the Orion Nebula itself, there are these Herbig-Haro objects. And these are newborn stars and likely solar systems with their own planets. And you can see that there's 4 of them here, and they're encased in their swaddling gas and dust. And the one on the far left, the brightish red one on the far left, with the dark spot in the center of it, here's a zoomed-in picture of that was recently released by the Hubble telescope team. So this is an amazing, amazing photograph. So hidden by that orange cloud in the center, hidden there is a brand new star, maybe only a couple thousand years old, a few thousand years old. And you may have heard about cosmological jets. If something called a neutron star emits a cosmological jet, well, that jet of radiation can occasionally sweep in our direction, and we see it as a pulsar. Galaxies, especially the centers of what are called active galaxies, can emit cosmic jets. Well, this is a jet being emitted by a single star, and it's material that is being sloughed off from the pre-solar nebula by this star. It's being thrown away. And some of the materials certainly is still around the equator. You can actually infer the axis of rotation. This is the axis of rotation of this star because the material is ejected axially. And some people have equated this particular image and these particular jets, the north and south polar jets of this star, to a lightsaber. Those of you who are Star Wars fans might be able to see a lightsaber in this image. And it's just spectacular that we, human beings here on Earth, from thousands of light years away, can witness the birth of a new star in its solar system in astounding detail.
Now, are you saying that those lines are in conjunction with the North and South Pole? Because you'd think
yeah.
that if things would be thrown out, it would be almost thrown out centripetally, or...
Yeah, some of it is sent out centripetally, but some of it is aligned with the magnetic fields, in the north and south magnetic field, which is often, though not always, aligned with the axis of rotation because of the way material sloshes around inside. And so a lot of these jets and a lot of cosmological jets are due to particles being accelerated in the polar areas of the magnetic field of these rotating objects. So here's another similar object, and this is a zoomed-in picture of another baby star and its jets. Just amazing. And it's dark there in the center. It looks kind of like a yo-yo. That's because a lot of gas and dust that is opaque is collected there around the center. So it's almost certain that there are planets embedded in that disk around a newly born star. Talk about cosmic ornaments. These are just spectacular, red and green. They're even the right color. All right, another kind of cosmological entity that scientists are intrigued by are things called planetary nebula. And these are typically balls, although from our perspective, they look like two-dimensional rings, but they're balls of gas, and or spheres of gas, bubbles of gas. And they've been puffed out by stars similar to our sun that have aged to the point where they're no longer able to sustain hydrogen fusion in their cores. And when they puff out their outer layers and lose a lot of their mass, that outer layer envelope of the star wafts away in space and becomes these glowing bubbles, energized by the remaining heat and light energy emitted by the star. And that bright white dot in the center is in fact the remnants of the star that puffed out this bubble of glowing gas. And remember what I said earlier about hydrogen being red and oxygen being blue and sulfur being yellow. You know, you can look at photographs like this, and scientists have looked at photographs like this and discerned the elemental composition of stars and the nebulas just by seeing the wavelengths. Now, if there were planets in orbit around this star is a couple billion years, 2 or 4 billion years older than the star that we orbit. If there were planets there, those planets were in for a bad time when their star went through this nova phase of puffing out its outer layers. Not only did the star cool down considerably as it collapses in on itself and becomes that white dot, but also the gas and dust that it emitted in the process likely would have stripped away a lot of the atmosphere of some of the planets that would be in orbit. Well, that will be the fate of the sun and our solar system a couple billion, 2 to 4 billion years from now. It's anticipated that our planet will remain clement and amenable to life for about 1 billion years more, and then our sun will start acting up a bit, heating up, and the increased heat will eventually boil off the oceans and whatnot. But there's lots of stars out there, billions of stars in our own galaxy, so hopefully within the next 1 billion years we work out how to actually build one of those spaceships, etc., or we find a way to colonize some of the outer moons in our own solar system to stave off the fates of solar death. But how beautiful.
Yeah.
How beautiful the remains of a star are.
Is that considered a red giant now?
Not any longer. So right when it was puffing out its outer layers, it would have been a red giant, but now it's collapsing into a white dwarf star.
So those are still accepted terms and thoughts in
Yes.
astronomy. That hasn't been more knowledge gained that's kind of thrown that out of.
Right, yeah. Red giants, our star, the sun, will eventually become a red giant. Its outer layers will, of plasma are likely to reach all the way to Earth, or very close to Earth. So bad days ahead for our planet, a couple billion years hence, maybe 3 billion years hence. But before, like I said, even before that, the sun will get hotter and start being a danger to life on Earth.
Congress better do something.
Well, good luck with that. I don't know. Might take them 500 million years just to convene the committee. All right. Next, we've got this thing, which is another planetary nebula. Now, one of the things about planetary nebula is they're relatively small. So compared to the Orion Nebula, they are much smaller because they're just the outer layers of a single star that has puffed out some gas and dust. And the Helix Nebula that I showed you just a moment ago that is the, visually speaking, in terms of our perspective from Earth, visually speaking, that is the largest nebula, planetary nebula we can see. By the way, they're called planetary nebula because the astronomers who first saw them discerned that they were disks instead of points of light, and they thought that they were planets. So they're called planetary nebula. But these are some of the most gloriously beautiful objects available to us in the cosmos.
That looks like a gem.
Yeah, it's just amazing. You can see, I could have filled this whole presentation with nothing but pictures of planetary nebula, and I think you would have all been pleased. You can find galleries online of planetary nebula, and they're just, each one is different. Each one is spectacular in its own right. And sometimes the material that's thrown off of the stars is thrown off kind of in an hourglass shape. rather than a bubble. So some planetary nebula have a more complicated geometry than just a sphere or a bubble. And sometimes the material that's thrown off collides with other gas and dust that existed in the system and creates wakes, like the wake of a boat. And that's kind of what you see in this. All those little streamers out towards the edge are the material of the sun coming into contact with material from the left over from perhaps its own pre-solar nebula. Absolutely gorgeous things, worthy of being ornaments in their own right. So, speaking of absolutely gorgeous things, this is absolutely amazing. This is Eta Carinae, and it is a star in the southern constellation of Carina. And about 1880 or so, this star went through a temper tantrum. Now, the latest thinking is that it's not just a star that expelled lobes. Remember, I was talking about that kind of hourglass shape. This is not something that expelled just lobes of gas. Rather, the current thinking, there are several theories, but one of the more commonly accepted ideas is that there are three stars in close orbit to one another, and one giant star gobbled up material from another relatively close by giant star, and that extra material caused a titanic explosion or a nova event. This star has not obliterated itself as a supernova. So some of you who know a bit about astrophysics may presume that this is a supernova. This is not a supernova. This is somewhere between a supernova and a regular nova, and it's the only one that scientists have ever found in this category. And they think it's so rare because it does involve a very special kind of statistically improbable interaction between more than one star.
Bunch of set of circumstances all had to come together.
Right.
Yeah.
To create this just gorgeous object. And here's a time-lapse motion capture. If you see down there at the bottom of the image in the viewport, you can see the time stamps of this. And it went from like 2003 to 2008. And you literally see this cloud glowing.
Or 1995 even.
Yeah, let me go back and do it again. So the two bright stars there, you know, are not changing their position because for all practical purposes, stars don't move over such a short period of time. But here over this period of time from 1995 to 2008, this has literally expanded. We can see it happening. All right. Next, this is, let's see, we're going to zoom in. I believe this is a NASA video. You see Orion, the constellation Orion there, kind of towards the top center of the image. The giant red star Betelgeuse, which I'm only going to say once, not tempting fate. So there's Orion, and we're going to start zooming in here to see what we can find. So here we go. I hope this, yeah. Different constellations in the night sky, and now we're zooming in. Bunches and bunches of stars, tiny stars, really only visible to really powerful telescopes. And look at this, buried within this ocean of nondescript stars is this thing. Look at this thing. Isn't that amazing? So this is a star that also underwent a nova. It sloughed off its outer layers. But what you see here in this time lapse is not the outer layers of the star. What you're seeing is what's called a light echo. So this star is and always has been surrounded by its own cloud or cocoon of gas and dust. And when it had its temper tantrum and released a gigantic pulse of light, that light was reflected. And here's another image of it. That light was reflected off of the gas and dust that already existed around it. And for a while, for a brief year or so, it looked like this, kind of like a glowing red eye. And then I think I've got another time lapse here. Yeah, watch this space. First it was blue as the flash of light initiated, and then it turned into this gorgeous thing. And this is from the last photograph in this frame is from 2006. So by now, it has essentially dissipated and not much to see there. So a short-lived but glorious cosmic outburst, highlighting one of the more beautiful things we've ever seen in the cosmos. Speaking of stellar outbursts, so this is M1. The names I've talked about, the Wild Duck Cluster is M11, Orion is M42. This is M1. That's the Messier catalog. Charles Messier, in 1764, French astronomer, was busy hunting for comets. And he kept finding these fuzzy spots in the sky that did not move or change like comets do. And he wanted to let other astronomers know about these fake comets. So he made a list, a catalog of these misleading objects, which look fuzzy, but you need not spend any time looking at them because they're not, in fact, comets. They're not very interesting. Well, it turns out that they are all very interesting for different reasons, but nobody in the 1764 era had telescopes powerful enough to discern some of their more fascinating features. But he made this catalog. Eventually it contained about 110 objects, M1 through M110, one of which is misleading. It's fake. He thought he saw something, but he didn't. So there's about 109 real objects there. Soon after him, William and Carolyn Herschel, who discovered the planet Uranus, in 1786 made their own catalog of fuzzy bits, and they called it the General Catalog. And it included Messier's objects as well as many others that they discovered with their slightly more powerful telescope. And then came John Dreyer. Remember, John Dreyer is the guy who took that picture of the of the Orion Nebula that to our eyes looks like a poor quality photograph. Well, in 1888, John Dreyer published what's called the New General Catalog of Fuzzy Bits. And of course, he didn't call it fuzzy bits, but a New General Catalog of nebula. And we still use that. So many of the galaxies that you would look up on the internet or see pictures of from Hubble and other telescopes have an NGC number. And that's the New General Catalog, as new as 1888. So some of these things that I'm going to be showing you here in the immediate future have these NGC numbers. And this is a star that had such a violent temper tantrum, it literally ripped itself apart. And this is the Crab Nebula, one of the closest supernova remnants. And there's a glowing white dot in the center of this. In this case, that's a neutron star. That's the remnants of the material in the Progenitor star that has collapsed to be about 14 miles side to side. So the size of a medium city is this stellar mass object in the center of this, and all the energy and material that lay beyond that was expelled in a violent explosion. And this is a composite from X-rays. Mike was talking about it earlier, from X-rays, visible light, etc. And by the way, here's the size of that Crab Nebula compared to the moon. So if you wanted to look at it through a telescope, if you have a telescope that can zoom in on the moon to such an extent that this is what you see of the moon, you could also potentially make out the Crab Nebula. But again, it's so dim that even looking at many of these things directly with your eye through a telescope is not nearly as glorious as seeing photographs of them, because the photographs can expose long duration and capture some of the fainter detail. This is the heart. This is an actual photograph of the heart of the Crab Nebula. It's a photograph made in light that is not in the visible spectrum, but still, you can see one of those jets that I was talking about starts off coming out in a straight line and then gets bent by, I don't know, its collision with other gas and dust, or maybe a kink in the magnetic field. I'm not certain. But this, just glorious. This is an actual photograph of the heart of the Crab Nebula, with everything centered around the neutron star. And that neutron star does have a beam of electromagnetic energy that sweeps back and forth, and it's, because of that, it's a pulsar. And here's a time-lapse photograph of some of the waves of energy coming off of that pulsar. Real photographs, real movies made of this. All right, this is a thing called the Spaghetti Nebula. This is also a supernova remnant, kind of like the Crab Nebula, except this one is a lot older. It is, let's see, I think it is something like 2 million years old, on the order of the same age as the Barnard's Loop in the Orion Nebula. And this thing is gigantic if you were to look at it in the night sky. Again, Hubble and other space telescopes and some of the biggest telescopes on Earth can't photograph this in its entirety because it is so large. In fact, compared to the moon, here's how big it is. So why don't we see this? We can see the moon. Why can't we see this Spaghetti Nebula? Again, it's just too faint. You have to have a long exposure photograph to see it. The Hubble telescope, by the way, I just put that little square up on the screen. That is the field of view of the largest, most widest aperture, the largest field of view that the Hubble telescope has. So by comparison, that's called the wide field camera on the Hubble telescope, and that's as big as it can see. So when the Hubble telescope takes pictures of certain large objects, it stitches together many different images from its wide field. But you see why it would be really challenging for the Hubble telescope to take an image of this Spaghetti Nebula.
The time frame to do it, you'd have to get long-term
Right.
photographs of each little pixel almost.
Right.
Yeah.
So shout out to the Hubble and its sister telescopes. You know, you don't have to go into deep space to see glorious celestial phenomena. You can see the northern lights from many places on Earth. Occasionally, you can even see them here from Illinois. This is charged particles from the sun that slam into the Earth's magnetic field and atmosphere and create a glow in response. And, you know, speaking of northern lights, they're up towards the pole where other things potentially happen. All right, and here's, now we're leaving our galaxy again. This is something called Caldwell 78. This is a globular cluster. So this is a globular cluster that is anomalously rich in metals. Remember, that's heavier elements. And beautiful, just bejeweled cluster of stars. And this is visible from the southern hemisphere, so we aren't able to see that with our telescopes here from Illinois. But there are many globular clusters, including the Great Cluster in Hercules. This is just one of the more beautiful examples of a globular cluster, a little spherical beehive-like agglomeration of stars that orbit as a mass around the center of our Milky Way as independent objects. And speaking of galaxies, this is the closest, most spectacular large nearby galaxy. This is about 2.5 million light years away. And light that we captured today was leaving this galaxy about the time the first hominids were walking around in the plains of Africa, Australopithecus and whatnot. And you know, this light you can capture with a camera lens. You can use, like I said, about a 200, 300 millimeter lens to get pretty decent pictures of the Andromeda galaxy, as long as you have some ability to track the stars. And the Andromeda galaxy is glorious, and you see the dust lanes and the spiral arms and whatnot. And it's actually much larger than the full moon also. So if this galaxy is so large and so close, why don't we just see it, obviously, in the sky? Well, space is mostly empty. And that darkness overwhelms the brightness of even billions of stars that are spread out many light years apart from one another. So the surface, what's called the surface brightness of these objects is relatively low. In a dark sky, away from city lights, if you gaze up at the constellation Andromeda and Cassiopeia, you can just make out this little fuzzy nucleus that corresponds to the center of the Andromeda galaxy, but you don't see an arcing pinwheel of stars like you can see through a telescope. The surface brightness is just too low. And to help you understand how real that effect is, think about the Milky Way. We're embedded in a galaxy that's almost exactly the same size. The Andromeda galaxy is actually spread out a bit more. It's about twice as big physically. But in terms of total mass, the Milky Way and the Andromeda galaxy are about the same mass with about the same number of stars. And here we are embedded in this compact spiral galaxy we call the Milky Way, and yet seeing the arms, the bright glowing arms that constitute the majority of the billions of stars in our own Milky Way, even seeing that is challenging unless you're under a dark sky. Again, that's because space is mostly empty and dark. And the pinpoints of light coming from individual stars just can't overwhelm that darkness without a long exposure or a very wide lens, much wider than our eye.
Although people could see the Milky Way a lot easier 30, 40 years ago.
Right, because of light pollution and whatnot. So you can certainly see the Milky Way, but it gives you some idea. Here we are embedded in a brilliant galaxy, and we can just barely make out the ocean of stars constituting the bulk of the Milky Way. And how much more difficult is it to see another galaxy that's 2.5 million light years away? Speaking of galaxies, this is one of...
Isn't the Andromeda closer than that?
2.5 million light years.
Okay.
Yep. And then here's one of my favorite galaxies. This is called the Sombrero Galaxy. You can see this in the summer skies towards the south. This is about 5 or 8 times the mass of the Milky Way. So this is a gigantic galaxy, and this glowing fog in which it's embedded are innumerable globular clusters, like I showed at the beginning of this section. So we see this galaxy as it is nearly edge-on from our perspective, and the lanes of gas and dust, which are the raw materials for star birth, bisect this image. It's just spectacular. And here is this galaxy compared to the size of the moon from our perspective. And then here's another beautiful galaxy. This is actually 2 galaxies interacting. This is called a barred spiral, B-A-R-R-E-D, barred spiral. You can probably see why. And it's got a beautiful inner nucleus with gas and dust lanes, and the bluish ring around its nucleus, right near the center of the nucleus of that galaxy on the left. That's an area of star birth. Newborn stars are brilliant blue and hot. And typically, galaxies like this will also see star birth in their as shock waves move through their outer arms. And this galaxy is interacting with a nearby galaxy. You can find some pictures of this pair on the internet where you can see the faint arms of the large galaxy being tugged toward and stretched out toward the smaller galaxy. This is called a flocculent galaxy. This is from the New General Catalog from 1888. This is NGC 2775, and this is a flocculent or feather-like galaxy. Just look at the colors and the textures in that. Isn't that remarkable? This is probably my favorite galaxy, so I've named it that, Scott's favorite galaxy. This is NGC 4921. And this galaxy is kind of special. It's what's known as a red and dead galaxy, though. So this galaxy, despite its beautiful milky appearance and the structure that you can see in it, there's not much new star birth going on in this galaxy. So the stars that it has, largely speaking, are all the stars it will ever have. And so it's, once the stars that you see here in this image burn out, the galaxy will fade from view. So these are called red and dead galaxies. A lot of yellow and red stars at the midpoint or later in their lives, even though the galaxy of this image is white. And then here's a strange galaxy, the only one like it that's ever been spotted, called Hoag's object. Looks like maybe the result of throwing a pebble in a pond with a ring of protuberance moving away from the center. So this may, in fact, be due to a galactic collision. The problem, and astronomers do see galactic collisions that result in an image like this, or in a structure like this. However, in this particular case, there's no bullet. Astronomers have not been able to identify any other nearby galaxy that might have collided or coalesced with this one. So it is literally a mystery about the astrophysical processes that might have formed this galaxy. And then there's this, which is an Einstein ring. This bright spot in the center of this image is a galaxy. And that blue ring around it, kind of horseshoe-shaped, is not part of that galaxy. That is literally an image of a far more distant galaxy. And that image has been amplified and distorted by the gravitational effect, warping space and time, from this intervening reddish galaxy in the center, which serves as a kind of gravitational telescope.
Like a lens.
Yeah, and in fact, it's called gravitational lensing, and these effects are Einstein rings. Another beautiful cosmic ornament. So that's it. That's what I had for today. Some of the most beautiful objects that I know about in the celestial sphere. I invite you to explore these more on your own. Do a search for planetary nebula gallery. Look up globular clusters and hydrogen clouds, etc., and you can find some of these and learn more about them on your own. Mike, have we had any comments or questions on YouTube?
I think people have just been awed that it's been silent on the YouTube.
All right.
Nothing has come through.
Well,
Yeah, those are just amazing there. Those are actual, you just crafted from some of your pictures of galaxies
right.
and then put the little ornament hanger on them, but those are actual 4 pictures of actual
Right.
galaxies.
And you can do that, if you want to make scientific decorations for the holiday season, find some of these pictures and have your own craft project with them. And oh, by the way, December 25th is an important birthday. I hope you all remember that.
Very critical.
Very critical, epochal, really, in human history, December 25th. I hope we all celebrate Newton's birthday. All right. Thank you very much for tuning in. Mike, you'll talk to these fine folks again in a couple weeks about viruses. And then
Vaccines.
Vaccines. And then I'll be back in mid-January to talk about a social science topic regarding the idea of merit and meritocracy.
Very good. And then we're going to have Steve coming up and talking after that in February.
All right. Look forward to having you all tune in again. In the meantime, if you do have questions or comments, you can put them into the comments of YouTube even after this video is published and we stop being live.
Here's a question from Peter Marinelli. How do astronomers pick out distant galaxies without light interference from other entities?
Yeah, so like I said, that's a great question. Thank you, Peter. Like I said, space is mostly darkness and empty. And there are gaps in the sky where there aren't any intervening stars between us and a distant galaxy, or few intervening stars. And the galaxies are extended objects, much larger than a point source of light that corresponds to a star. Light pollution, though, from things like cities, is a problem for astronomers. So is atmospheric turbulence, and that's one of the reasons that a lot of the major professional telescopes are built on mountaintops or in remote areas like the Atacama Desert of Chile. so that they can get away from both light pollution and get an elevation to get above a lot of atmospheric turbulence. So it's kind of hard, 300 years ago, the skies would have been darker for everybody. But even from my backyard, so I'm going to just zoom forward a couple slides here. This is a picture I took from my backyard. And it's part of the Orion Nebula complex. And then here's another picture I took from my backyard. So I live in Oswego. Talk about light pollution. There's still light pollution there. But with a modest telescope, I'm able to get pictures of some of these things, including some pictures of galaxies, which I'm not ready to publish yet. But
Do they filter them out too, though? I mean, do they filter out things that aren't common to?
yeah, great question. So you can buy, for your telescopic camera, you can buy special light pollution filters that filter out things like sodium light, specifically, because we have a lot of sodium street lights. And one of the problems is, as we move from sodium street lights to LED street lights, the LED street lights don't have as narrow a band of frequencies as something like sodium street lights. So it's harder to filter out the light pollution from LED lights, even though they're more environmentally friendly. So there's a whole other talk that has been given, I don't think by me, but I think we had somebody here a couple years ago talking about light pollution. But yeah, you can do this. You can see these objects. You can photograph these objects, at least, even from suburban skies.
Part of it, the telescope has to be equipped with a device that tracks the star and overcomes the effect of the rotation of the Earth, right?
Right. Yeah, exactly.
So, and that's the only way that you can keep a certain object in the center of the.
Right.
And you do that with your computer and tied into your telescope.
Yeah, I and most amateur astronomers these days, we use all electronic cameras and electronic control of the telescope and all of that. So.
But you do want to have that frame open and that thing focused on one spot, and to do that for maybe 30 minutes or
hours sometimes.
Okay.
Typically, the light pollution can overwhelm an image if you try to have the shutter open for more than about 30 minutes. But you can take many 30-minute or 10-minute or even 5-minute exposures and then what's called stack them to overcome the signal-to-noise ratio challenges. So, but thank you for the question.
Great. All right, and Peter thanks us for the response.
All right, thank you all. Stay safe. Have a good holiday.
And
Talk to you soon.
Thanks to Todd up top there. You got it going really well.
Thanks, Todd.